My name is Sankar. I'm an applications engineer at National Instruments, Singapore. Today we are going to show you how we can program and run a printer using Labview as a programming platform and the Compact Rio as the hardware platform. This is the printer setup. We have a print head which is controlled by the servo motor which is located here. And also you can see that there's a paper feed assembly which controls the feeding of the paper, which is controlled by a stepper motor which is located at the back. All these three components, the print head printing the ink, the servo motor as well as the stepper motor, is controlled by the Compact Rio. Here we have the Compact Rio real-time controller, the NI9505 servo drive, as well as two industrial digital output modules, the NI Compact Rio 9474, which will control the stepper motor as well as the ink cartridge firing. The printer prints. We need to have an idea about two things. First is how to control the firing of the ink cartridge. This basically is how to control the digital output so that each nozzle fires an ink dot on the piece of paper. The next thing we need to do is to figure out how we control the printer head. So we start off by looking at how we managed to find a controller to control the print head. We used three toolkits in this procedure. One is the Labview system identification toolkit, which basically helps us to send a stimulus signal to the printer and get a response signal, and then identify the particular printer model from that. Thereafter, we use the control design toolkit to find an appropriate controller and to test different types of controllers to see which one suits better for our particular application. Finally, we need to run some simulation applications. We used the Labview simulation module to run the simulation of the controller that we designed. And finally, we used the Labview real-time module to download the controller that we designed onto the Compact Rio real-time embedded controller. Let me show you now how the previously mentioned toolkits help us to design the controller for our printer project. First of all, let's look at the system identification toolkit. Here we have a Labview VI designed, which shows the stimulus signal that is sent to the print head using the Compact Rio, and also the response signal obtained by the encoder of the print head. Let us take a look at what kind of options are available for us to process this input signal. We will be able to obtain the amplitude and frequency response and also apply certain filters if required. Also, we will be able to do certain model estimations and also identify the different prediction errors that are there for different models. We will be able to specify to what extent our model order is by specifying the necessary inputs. Once a particular model is recognized, we will be able to enter the model orders here and have certain plots that are used to identify how the model response would be like. Here you could see a pole 0 plot as well as the plant discrete transfer function and how the plant discrete transfer function is converted to a continuous transfer function. Also, we could analyze Bode magnitude plots as well as Bode phase plots. Finally, we'll be able to use the obtained printer model and send a stimulus signal and see what the response signal is like and match it with the actual response signal that we obtained from the printer head. Let us take a look at the block diagram. You could actually see that most of the components that we used just now is already embedded into certain VIs by the system identification toolkit. For example, the pole 0 plot is one single VI, and it gives us directly the pole 0 plot output as the graph. Also, you could see that the transfer function conversions also are single VIs, and the displaying of transfer functions also is very simple. Similarly, all the other functions that I mentioned to you just now are added in. This is the model estimation VI. As you can see, this kind of application is very simple to build with Labview and the system identification toolkit together. Now let's look at the control design toolkit. We run the control design toolkit VI and we load the previously identified system model. The system model that we designed previously could be saved as a .lti file extension and used later on in the other toolkits. So once the system model is loaded, we will be able to analyze it using different types of controllers. Here is the standard PID controller design for the particular system model. We will be able to change the different PID values as well as some of the overshoot values and thresholds so that we can design the optimum controller that we want to. Most of this VI is actually taken from the example VIs that are provided together with the control design toolkit. We could also use customized controllers, like for example this particular controller which has the gain, a pole and a 0, and we'll be able to save this particular controller as one of our controller models for the particular system model we identified previously. The next step would be to use this particular controller and to do some simulations to see whether this is the controller that we want. Let us now take a look at the Labview simulation module. We use our previously saved plant model as well as the control model files and then run a simulation using a square wave and the particular amplitude and frequency specified over here to see what kind of a response our system has. So by sending different input signal values, you'll be able to simulate the data output from the particular controller and then analyze whether it suits your particular application. Let us look at the block diagram. As you can see, our printer model as well as the controller model is loaded from the files, and we have designed our feedback controller using the different icons that are available using the Labview simulation module. The black color loop that you see here is the simulation loop that simulates the data input as well as the response from our particular model and the controller together. Once we have finished simulating our controller, we'll be able to download the controller into the real-time target using our Labview real-time module and then test it for real. Thank you for watching this video. If you have any query or questions regarding this, you could email us at asian@ni.com.